Today we're diving into the world of artificial intelligence to try to understand how it works. AI is like teaching computers to think and learn, just like we do. Let's start with some basics. In AI, we have three important things to know: algorithms, complexity, and heuristics. It's important to understand algorithms, complexity, and heuristics because these concepts form the foundation of problem-solving and decision-making, which are an integral part of AI. Algorithms are like recipes for computers. They are like step-by-step instructions that computers follow to solve problems efficiently. Imagine you're baking a cake. You follow a recipe step by step to make sure the cake turns out just right. Similarly, imagine you have a big pile of toys all over your room. You want to put them away neatly, so you decide to sort them by size. First, you pick up a toy and see how big it is. Then, you compare it to the others and decide where it belongs. You do this for each toy until they're all in the right place. Algorithms are like a set of rules that tell computers how to solve problems in a similar way. For example, if you have a long list of names and you want to find a specific name quickly, the computer uses an algorithm to do it. It looks at each name, compares it to the one you're searching for, and keeps going until it finds the right one. This helps computers solve tasks quickly and accurately, just like sorting your toys helps you tidy up your room.
You may have heard the term algorithm recently, whether it was online or maybe in some conversation about technology. It's a word that gets thrown around a lot, but what exactly does it mean? Well, simply put, an algorithm is a set of steps used to complete a specific task. They're the building blocks for programming, and they allow things like computers, smartphones, and websites to function and make decisions. But in addition to being used by technology, a lot of things we do on a daily basis are also similar to algorithms. Let's say you want to make some spaghetti. In order to do this successfully, there's a certain set of steps you need to follow in a particular order. First, you need to boil a pot of water. Once it's boiling, you then add the spaghetti and cook it for a set amount of time, stirring occasionally. Once it's finished, you drain the water and then it's ready to be served with a sauce of your choice. That entire process is actually an algorithm. Because you followed those steps in that order, you reached your desired outcome, a delicious pasta dish. But if you were to make a mistake, say over or undercooking your noodles, it probably wouldn't be as good. Programs work in a similar way. Their code is made up of algorithms telling them what to do. Let's say that we want to use a navigation app to get directions. When we punch in a destination, the app uses an algorithm to look at the various available routes. Next, it uses a different algorithm to check the current traffic. And then a third one takes that information and calculates the best available route. All of these algorithms are built right into the app's code. If there were any kind of error in that code, the app wouldn't be able to follow these algorithms correctly, meaning you wouldn't receive your directions. Both of these examples show how both humans and computers can use algorithms to perform everyday tasks. The difference is that computers can use algorithms and calculate things better, faster, and more efficiently than we can.
Now we will be talking about the second point, complexity. Complexity is all about how hard a task is for a computer. Understanding the complexity of tasks helps you identify the resources and time required for the computer to solve problems. For example, using Google Maps to find directions from your home to a nearby grocery store is relatively easy. The app quickly calculates the shortest route based on the distance and traffic conditions, and you reach your destination without much hassle. However, imagine you're planning a trip to Rome. If you're planning a sightseeing tour of the entire city, including multiple attractions spread across different areas, the task becomes more complex. You need to consider various factors like traffic patterns, distance between attractions, and opening hours. planning such a complex journey requires more time and effort. And if it had to be planned by an AI system, the resources available and time taken to plan the journey would be significant. Picture yourself trying to find your way home from school. You might not remember every turn, but you know the general direction and landmarks along the way, so you use those clues to guide you. That's a heuristic, that is, solving problems based on past experiences. In another scenario, let's say you're at a supermarket trying to choose the ripest fruit. You might not know the exact criteria for ripeness, but you use your past experiences, like looking for bright colors or feeling for softness, to make an educated guess. That's another example of heuristics in action, that is, using your past experience to choose the best fruits available. In video games, when you encounter a new level or challenge, you might not know the perfect strategy right away. But based on similar situations in previous games, you might try certain tactics or approaches that have worked before. That's using heuristics to figure out the best way to progress by remembering what you've learned in the past. In sports, like football or basketball, players often rely on their instincts and past experiences to make split-second decisions during a game. They may not have time to think through every possibility, so they trust the gut feelings and go with what's worked in similar situations before. That's another example of heuristics guiding actions. Overall, heuristics help us make decisions quickly and efficiently by drawing on our past experiences and intuition. Whether it's choosing the best move in a football match or navigating through daily life, heuristics play a crucial role in helping us navigate the world around us.